Hello, everybody. Good afternoon here on East Coast time. And I'm so thrilled to introduce Randy Carlisle. And he's going to be talking about predictive maintenance isn't just a program, it's a medical checkup. And I want to remind everybody of the Play to Win code. So this is Randy's code. So go to the Play to Win after the session, type in that code to earn your points to win. And Randy, without further ado, I'll head off to you.
All righty. So this normally would be a little bit of a longer presentation, so we're going to cut through some of it. Advanced notice here. I am not technologically advanced. I'm presenting my screen and I cannot see your comments. So if you're making comments, I apologize in advance. I'll try and get to them at the end. So what we're going to talk about, I'm going to make some assumptions that the folks on the call know what PdM is and have some fundamental understanding. Again, this would normally be a lot longer presentation, so I had to cut out some of the basic theory here. I'm not going to read this. I think they're sharing the presentations with you folks. That's my experience. I am certified maintenance and reliability professional and a certified reliability leader. Been doing this a long time. I've been an auditor. I'm an RCA leader. I like to tell people I'm your worst enemy when I come to the plant because I've done all this stuff. So here we go. First of all, a little bit of basics. Why do we do PdM? Is it just a program at your site? What I want you to get out of this presentation is thinking about some options. Okay, we're not going to talk about how to do analysis or anything like that. What I want you to do is start thinking about some options. And so here we go. So nothing runs forever. I know this is kind of strange to some managers, but it's a true statement. Nothing runs forever. So what we want to do is monitor the equipment without affecting the process availability or affecting the equipment. In other words, keep production up. Key point, if you're going to have a PdM program, you need to be looking for the symptoms that match the way things break. Okay? I know that sounds a little obvious, but there's a million people out there that want to sell you a million things to do to monitor your equipment. But if you're not monitoring the way it breaks, then you're spending money to get nothing. Once you figured out how it breaks and you're monitoring it, you absolutely have to understand how that equipment works in your process before you can understand your PdM results. Give you an example. If your vibration suddenly goes up at rotational speed and you're, oh my God, I think something's broken, when in reality, all that's happened is they've made some changes to your process parameters and there's more load or less load or whatever. So you have to know what's going on in the system. And then, of course, the ultimate goal of any PdM program is you want to repair or replace at the right time for the maintenance and key point for the business strategy. Okay, why do I say that? If you're one of those industries that runs 365 days a year from turnaround to turnaround, then all you want to know is, will it make it to the next turnaround or the turnaround after that? If you're one of those industries that routinely can shut down a line and do maintenance, then all you want to know is, how bad is it so I can schedule it, okay? You have to understand the business strategy that goes with your PdM program. Okay, so what are we going to talk about today? We're going to talk about 6 basic technologies. Vibration analysis, infrared analysis, oil analysis, a little bit about precision alignments, otherwise known as laser alignment, ultrasonic noise surveys, and motor testing. Okay. So quick basics. PdM is telling you the condition of your equipment. Think of it as a medical checkup for your equipment. And I created this little graphic a number of years ago. So what you can see here is you go to do a vibration measurement and you get some result. Well, your oil analysis will also tell you something about that equipment that may be affecting your vibration. Your motor performance, there may be some electrical issues in that motor that are causing the vibration. If you have vibration, you might also have some ultrasonic noise. Obviously, if you haven't properly aligned the equipment, that could cause vibration. So if you look at this chart, these are kind of interrelational things. And if you take all of these things and you start thinking about measuring some parameter, what can cause that parameter to change? And then you start looking at all these technologies and how they work together. If you've got a coupling that is visibly hot in your infrared survey, then you've obviously got something going on. But if you have no vibration and you have no motor issues and you know you did a good alignment, then probably the problem is just the coupling. On the other hand, if you've got a hot coupling and you've got high vibration and your motor's showing some issues, that tells you where to look, right? You probably need to go look at the motor. So all of these things are telling you some certain parameters that can be related to other surveys. So here's my favorite picture. This is the inside of a plant. In this building, there are 5 compressors. There's air, there's nitrogen, there's a couple other things. There's a chiller with Freon. There are 2 electrical switchboards, 480 volt and 4160 volt. There's a battery bank in there. There's a catalytic converter for argon systems. You start thinking about that graphic on the left there. Where can I get some useful information from my PdM program? How can I take advantage of some of this stuff? So we're going to go a little deeper. Again, my intention here is to get you to look at these slides and start thinking about, well, gee, what could I do with that at my plant? Am I trying to do that now? That kind of thing. Okay, so what are we looking at, right? Infrared is measuring heat. In other words, it's measuring the kinetic energy of whatever you're looking at. Vibration is measuring movement. You got an accelerometer or you've got a prox probe that's measuring some movement. Again, it's measuring a certain amount of energy that's involved in that movement. Oil analysis, there are too many things to think about in oil analysis, but the key point is you want to look at the things that apply to your equipment. I'll give you an example. If you're looking at a gearbox that does not have oil filtration on it, so it's just a big sump that's splashing up on the gears, you can probably assume that your particulate counts are going to be going up. You might not even want to do particulate counts in a system like that. On the other hand, if you've got a pressurized and filtered system, you definitely want to know how that system is working and whether you're getting dirt in it, things like that. Ultrasonic surveys are measuring ultra high frequency sound, but again, you're measuring the energy that is created by that noise. Okay? And motor testing, again, there's a number of things, but typically when you're doing motor testing, you're either checking for the condition of the insulation, or you're checking to see if the electrical characteristics of the motor are what they should be. Again, you can think about this as energy, right? The insulation resistance is to keep the energy in. The electrical characteristics are to make sure that the energy is doing the right things for you. Now I come back to oil analysis. If the energy in that equipment is going in the wrong places, you could wind up seeing things in your oil analysis, whether that's varnish or whether it's wear particles, same kind of thing. It's kind of an interesting way to look at it, but it's all about the energy. The energy is creating the sound, it's creating the temperature changes, it's creating the vibrations, but it's energy that you can see and you can measure. Okay? Here is a real life example. On the right, you've got an electrical motor. In the middle, you've got a coupling. And on the left, you've got a big pump. And then you got a guy in a blue shirt that used to work for me who's busy monitoring that thing. So what you can learn from this? I've got vibration I can do on the pump. The vibration can tell me a lot of things, right? If I'm doing vibrations on the pump, then I've got vane pass frequencies, I've got possibly ball bearing frequencies, I've got flow kind of frequencies, I've got balance frequencies, all of those things. Then you've got the alignment of the coupling and the motor and everything. Again, you can learn a lot, and you can learn a lot from trending by taking all of these things combined. Okay? Infrared will tell you if the energy is going in places you don't want it. Bearings should not heat up. Or the two bearings on a particular motor shouldn't be that much difference in temperature. So if one is cold and the other one is hot, there's something to look at. If the bearing on the non-drive end is hot and the coupling is hot, and you've got vibrations on the motor, but you don't have vibrations on the pump, you combine all that and you could probably say, I've either got a bearing problem or I've got a coupling problem that has manifested itself in that bearing. So why do I say it that way? When we design the equipment, right, you sit down, you try to figure this out, you're going to put X number of kilowatts or horsepower or joules or whatever into that process system. You want that pump to take water, pressurize it up, and move so many gallons per minute through the system. You crunch all the numbers in an engineering world and you get, hey, I got to have this many horsepower in the motor, a little bit of losses, and so this is what my system should run. So we want all of those amps and all of those, all that rotational energy to go down that shaft into the pump, and in a perfect world, all of that energy goes into the water. As soon as some of that energy goes other places, we have problems. Okay. And the interesting thing about energy is if you give it an option, it's going to go where you don't want it to go. If there is a problem in that bearing because you didn't lubricate it properly, the energy that is supposed to be going down the shaft is now going into the balls and becoming hot. Same kind of situation. You're doing infrared surveys on the transformer. You might have corona effects that you cannot see with the naked eye, but you can hear with the ultrasonic noise survey. Those corona arcs are energy that's going in places you don't want. If you have uneven heating on those insulators, that's energy going where you don't want it, and eventually can lead to a failure. What you're seeing here in this picture on the right is a couple of pressure vessels in an air separation process and a control panel. It's associated with some of the things on that skid. But as you can see, those things are fairly high. But up there in the upper right-hand corner, there is a vent valve that you can't reach. If you're standing in that particular spot where I took this picture, you also can't hear because it's a noisy plant. There's actually a big chiller unit to the left of this, not to mention an air compressor behind it. So if that little valve is leaking, you'll never know. Depending on what industry you're in, there could be temperatures issues, or in my industry, in the air separation industry, those are molecules that are going in places I don't want. I want every molecule that goes in the front end to come out the back end and go into a tank. So leaks are bad. But an ultrasonic survey pointed at that valve immediately shows that you've got a leak. Likewise, an infrared survey on that insulation will tell me if there's a problem. And so here's where I was talking about knowing your process and knowing your system. If you know that there is supposed to be a temperature gradient from the top to the bottom of that vessel, but you do an infrared survey and there's not, you've identified a problem. If you look at that and there's a big red spot right in the middle where there's supposed to be nice, even insulation, you know you have an insulation problem. If you didn't know how that process worked and you took a picture of it and it was all nice and even and the same temperature, except it was 70 degrees and it's supposed to be 180 degrees, you'll never know that you had that problem. So it's a perfect example of you got to know what the process is supposed to do before you can figure out what it's not doing or what it's doing wrong. Okay. Electrical panel, same thing. Infrared will obviously help with that. That's the traditional use of infrared. I'm going to show you another one here. Again, if you understand the energy and where it's supposed to go, you can track it down and make sure it's going where you want. So this is what I was trying to get at originally. The issue here is more about what you can do, not about what the vendor thinks you can do. And I tell my guys, we give them the tools, we send them out, I tell them, use your imagination. True story. First time I purchased an ultrasonic noise survey kit, I went to my boss, said, hey, I want to get one of these. Here's some things I think we can do with it. I bought every attachment that company sold. Every little sensor, every extension, every little fitting, everything they could possibly sell me, I bought it. And I sent the whole kit down to one of our plants that was just wrapping up a turnaround. And I told my lead maintenance guy, hey, as soon as the plant starts up, take this thing, go play with it. I'm not going to tell you what it can do. I want you just to go try every attachment, stand back, use the parabolic mic, play around with it, walk around, touch things, do whatever you want to do with it, just play with it. And in 5 minutes, he found a couple of leaky valves and we made a very significant increase in production. We found relief valves that were leaking that we didn't know about. We found vent valves that were buried inside places that we didn't know about. This was a particularly old plant. We found a valve under the insulation that had been leaking for who knows how long. So the question is not what the instrument can do. The question is, what can you do with the instrument? This is another one of our plants. As you can see, there's a lot here. There's a lot of piping. There's a lot of pumps and compressors and things, all of which have the potential to do integration of PDM results. And this is another one that, people don't necessarily think about. I had to crop this picture to make it fit a little bit so you could tell, but what you're seeing here is two pipes side by side. Behind where it says UT here is a pipe coming in. Behind where it says IR is the same thing. There's the pipe coming into this T, and then it either goes up or down depending on these valves. As soon as we walked over there with the camera, we noticed a temperature difference between the top and the bottom. And we had to sit back and think, well, is that supposed to be that way? In reality, no. There wasn't supposed to be any flow down the bottom. That was all supposed to be ambient temperature. So all the flow was supposed to go up. Well, unfortunately, we had flow going both directions. Same thing we did on the other side. The infrared didn't show anything, but what the hell? Let's put the infrared survey meter, the ultrasonic noise kit on there. And sure enough, valve on the top was open, the valve on the bottom was supposed to be closed, but we had leakage through there. Again, when your business is to take air and break it up and sell the molecules, we don't want the molecules going to strange places. So a couple of adjustments, fix that valve, improve production. All of these things, when you think about it, if you ask for an infrared survey from a company, 99% of the time, they're going to come out and look at your electrical panels because that's what we've always done. Same thing for ultrasonic noise surveys. Most companies will come out and they'll do a leak survey to tell you where you have leaks. But when you take a step back and you think about what are we really measuring? We're really measuring energy. Where can I make use of trying to make sure there's not stray energy? And wow, there are a lot of places you can go, a lot of things you can do. So if you take a step back and you think about it that way, there's a lot there. So I'm going to close out this presentation so I can see some of your comments. I got about 5 more minutes, so that's good.
Yeah, you're good here, Randy. So I'll pull these up for you so you can see them. And a good comment from Rahul about the most difficult thing is to convince management about a PdM program. And
yeah, funny thing about that, the noise survey kit I bought was about $12,000 all told, with all the different stuff that I bought. And I crunched some numbers and I said, hey, just leakage alone, if we can find a leaky valve on the air side, how much money could we make? There are some generic calculators out there that basically all of the companies that sell these tools will provide for you. You punch in some noise levels, you punch in some assumptions about valve size and it didn't take long to be able to say, look, if I can find 1 2-inch leak, I'll pay for this kit in the first 3 months. That was enough to let them, approve it. When you start talking about programs, it is much more difficult. And particularly if you've had a program and you've had some early successes, and now you're not seeing those big wins anymore, it's very easy for management to go, well, we don't need to do this anymore, right? We fixed everything. And the way I've approached it, and thank God, the company I work for has agreed with this concept. At some point, PdM becomes insurance just as much as it is solving problems. Good news or bad news, right? The bad news is we have a lot of plants, we have a lot of people. Not all of them are 100% on board with some of my programs. We have had a failure here and there where they didn't follow the program. Something broke and it was expensive. Good news is, well, that's a great counterpoint to go back to management and saying, it cost you this much to fix it now. Had we been doing what we're supposed to do, we could have replaced a bearing for, 1 day of downtime and $500. So unfortunately, you have these little wins that aren't really, but they help. So it's a question of what's good for the business and what are they willing to accept. So, all right, so I got about 1.5 minutes.
So I'll put another question from Rahul up real quick. So where will you place LLF in PdM program?
I don't know what LLF is. Okay.
Maybe we'll have somebody type in for that. But you mentioned earlier about approach this from a leadership standpoint, where you gave one of your team members a tool and said, "I'm not going to tell you what it does, but go, help improve the system." So, do you see these PdM programs? You've got to sell it to management, but how do you have change management, or how do you use it in your leadership style to implement it?
Well, because I always take the approach that new technologies can do new things, and there's no such thing as too much information. So the more I can learn about how the equipment is functioning without tinkering with the equipment, the better it is. And so I sit back and I think, oh, here's a technology that measures this. How can I use that? And I get had a lot of junior engineers, things like that. I get them on board to say, look, I don't want you to know what the vendor says. I want you guys to think about, this is what it measures. Our equipment. Where could we use this? And just let them go brainstorm. Sometimes you get good results, sometimes you don't, but you'll never grow if you just stick with whatever somebody else is telling you.
And I think that leads into that question we had before. So in terms of LLF is look, listen, feel.
Okay, I call that operator rounds. You'll never get, the problem now is you need the operator rounds for the process side, but the technology of PdM is now, before an operator can even see it, feel it, smell it, the technology is better and more accurate than the operators are. So you got to have both. And with that, we're out of time.
Okay, Randy, thanks so much for sharing your knowledge, your expertise, taking the time today. Thank you all for joining us. And there's some more sessions coming up, so enjoy the rest of the day with LRVS. Thank you.